Okay, you can just open the file. It's in the different example 2021.r. Okay, so this is a file because I just updated last night. Uh, but that's fine. You can check out the codings because I created this file a few years ago, but I don't have enough time to improve the contents of the coding. So maybe this year I will spend more time adjusting the codings in there. So basically, we have a three asset example, right? So you can just download the file and copy the file directly. Okay, but I will explain a little bit about the coding. Okay, so just give me a minute and I will open the file. That's better now. Uh, Sorry, I don't have a very good formatted codings because you're gonna see a large amount of codings in there, and this may seem very confusing to you. Okay, but let's just focus on some basic problems. Okay, so first of all, you always need to import data. Okay, so this is the first step, and the second step you need to analyze the data and try to fit the data into our modeling. Okay, so most of the time, especially for finance major student, you have to be very familiar with this process. The first step is import data. Of course, the second step is to do some exploratory data analysis, which we call EDA. But right now, I'm not we are not focused on this part because for EDA, probably you will learn a lot in other courses. But now let's focus on the financial models only. Okay. So now what we are talking about is the efficient frontier or Markowitz modeling of the minimum variance portfolio. So we need to find the minimum variance portfolio based on this example. So let's go to the first step. We need to import data. Okay, so I just give you some examples here. But anyway, this data is the same as the file I gave you in your homework. I just called it a three firm example. But don't worry about the other names, okay, following the three for example, but these are all referring to the same data. Okay, so the step one is to import data from Excel. Of course, if you have a file in Excel format, you can also import the data in Excel, but now I prefer to use CSV because most of the time when we have a very large data set in the future, CSV formatted file can save some storage space, okay, disk space. So I prefer you to become more familiar with the CSV. Okay, so for example, like we have several commands to read CSV file. Okay, the first one is the most traditional one. I call it as read.csv. Okay, so we can just read this file, import this file, And the second step, okay, this is the first step. The second step is maybe we need to convert data into time series data. Okay, time series data, we have the most traditional format. We call this as a XTS, which is time series format. But just like many R developers, they are developing new packages to generate time series data. Okay, so but this, just like I said, this is the most traditional format. So you still have to be, you still have to know the most traditional format. So in this case, let me run the file. Okay, now you can see after you import the CSV file, you will see the file, the date column is text format. Okay, so you can see the date is in character format. So we need to change the date to time series data. So we just load up the XTS file, and then we convert the date character into time series. Okay, so we can run the following commands. Library XTS, and then we use a function called as.date. Okay, so this is to convert the character date into time series format. Okay, and then we use as.xts. Okay, and complete the transforming of the character date series into time series data. Okay, so this is what we are doing. So now you can see we have a time series data here. So you can call up the data, and now you can see the index has been converted from 1 to 3 in numerical order to date order. So you can see this is the date format. Okay, but don't get yourself stuck in here, because this is just the example to help you to become more familiar with the time series format. Okay, so if you have some problems about the codings, don't get don't feel frustrated, because nowadays we have many AI to help us, okay, to find the solutions. Okay, so don't get frustrated with these codings, because most of the time I can't, of course, for take myself as example, I can't remember so many codings and so many functions in R. So I always have to refer to help to give me some guidelines. Okay, to for example, like transforming time series. Okay, so next section is another issue, because in the future you have to know how to import data from the market. For example, we're gonna use Quantimo package, because this package can help us to download the data from the website. Okay, for example, like Yahoo Finance, you will see many the different stocks prices, and you like to download the most updated stock price from Yahoo Finance. Okay, if you want to do that, you can use this package, Quantimo. This package can help you to download stock prices, okay, from the website like Yahoo Finance. So the following commands, like get symbols here. Okay, get symbols is a function of Quantimo package. So you can use get symbols, okay, to download the data. Okay, so for example, I define tickers to include the 3 stocks. Okay, JWN, SBUX, and NSFT. But of course, first of all, you still have to know the tickers for the stock. Okay, for example, the tickers for the Apple computer is AAPL, right? AAPL is the ticker for Apple computer. Okay, and the NSFT is the ticker for the Microsoft stock. Okay, Microsoft stock. If you want to make an investment, if you want to check the price of Microsoft, you have to know the ticker. So, but you can find the ticker easily through the Google. Okay, so there's no problem. So in the following, you can just follow these commands, and then you can just download the data, and then you can specify the time range from 2010 to 2018. Okay, but I just need you to practice this process. Okay, to become more familiar with the Quantimo, because Quantimo is very popular and very helpful to help you to download the stock prices from the Yahoo Finance, because in the future you're gonna handle this kind of problem as well. So try to make yourself to be comfortable, okay, with the Quantimo package. But now this is not our core issue here. Our core issue is to, okay, since we already have the data available, we need to find the minimum variance portfolio, right? Okay, so in the following, I just use some formulas, because we mentioned some formulas in the slides, right? Remember? We have some a minute. Let me download the slides first. Okay, so let's go back to our slides and check out the formula again. Maybe this is not required, but it's very important to understand the coding. So we can go to the minimum variance portfolio format directly, because it will be easier in this case. So now you can see, okay, we have a. Okay, so this is a formula for the minimum variance portfolio. It's very straightforward. Okay, you can see in the numerator we have inverse of sigma multiplied with one vector, and denominator we have transpose one vector multiply the inverse of the covariance matrix and multiply one vector. Okay, so what we are doing here is doing the same thing. We can generate first of all, we generate the sigma and the one vector, and we also find the inverse of sigma. So now we are using the solve function. Okay, solve function, and we can just generate the top matrix. Okay, top matrix is referring to the numerator section, inverse of the sigma multiplied one vector, and the bottom refers to the denominator. We are doing the same thing, but just multiplied by the transpose of one vector, and finally we can find the minimum variance portfolio weight. Okay, so this is the solution. Okay, for the first problem. Okay, This is not that difficult because you can try to copy the codings and run the codings by yourself. Okay. And then the second thing is about this is the minimum variance portfolio weighting. And based on this weighting, we can calculate the return. Okay, so minimum variance portfolio return. And similarly, we can also calculate the minimum variance portfolio standard deviation. Okay, so this is about the standard deviation, the expected return, and the optimal weightings for the MVP. So we call this the GMVP, okay, global minimum variance portfolio. Okay, the second problem is about what if we have a given return to find the minimum variance portfolio. Okay, so this is about the find the optimal MVP for given return. Similarly, we can also refer to the slides here. Okay, so this is one way to find the MVP for given return. So basically, you can see here, I just use actually I use two ways to do that. But remember, the first way, okay, the first way is to just plug in to the formulas. So you can see here, we have a formula here. Okay, we try to construct a formula like Zx. So Zx equals to inverse of matrix A multiplied by B0. Okay, so what we are doing is to replicate the formula here using the codings. We can go back to the codings here, and you can see what we are doing here is, okay, we have a Z R0 because now we are using monthly return. So I just divided the 0.06, which is the annual rate, divided by 12, so that I'll get the monthly return, a monthly risk-free rate. Okay, because our data is monthly returns, so I just use the R0. And top dot matrix, we are using the formula here. Okay, so you can see here top matrix actually is the AX. Okay, so you can see AX is composed of 9 elements, but in fact we only have to set up the first row or first column, which is 2 sigma followed by the mu followed by the 1 vector. So let's go back to the coding here. So now you can see we have a top matrix. So let me run this. Okay, now you can see the top matrix here. Let me show you here. Okay, top matrix. Okay, now you can see this is the, okay, this Nordstrom, Starbucks, and Microsoft. This is the 2 times sigma. Okay, 2 times sigma, and then followed by the mu vector. Mu vector is here. Okay, this is fourth column, and the repeat 1 by 3 times. So this is 1 column vector. So you can see this is 2 sigma followed by the mu vector and followed by the 1. So let's check out the slides here. So you can see we are constructing actually the first row of AX matrix. Okay, the first row of AX matrix is 2 sigma, mu, and 1. Okay, so we are doing the same thing here, but just by coding. So this is the first row of the AX, and then we have a mid vector. Okay, mid vector is mu 0, 0. So let's run this and to see what happens here. Mid dot vector. Okay, mid dot vector, we have a mu followed by the 0, 0. Okay, so let's check out the slice here. Okay, we have a mu plan. Okay, it's a row vector now. We follow by and then followed by the 0, 0. Okay, so sometimes if you look at the matrix formula, you can't fully understand what is going on. Okay, because you are not so familiar with the matrix algebra. Maybe you haven't learned or studied this course before, but never mind. Okay, never mind. Just put it aside. Let's focus on the new numbers. Okay, numbers we are constructing the AX. Okay, we are constructing the AX. So we are just doing the same thing here. Okay, so mid vector. Mid vector is referring to the first three elements is the mu or average return of 3 stocks, and followed by the 0, 0. Okay, now you also have to check out the dimension to make it make sure that it's consistent, because we have a top matrix. The top matrix actually is the dimension is 3 by 5. Right? We have 3 stocks, which means we have 3 rows, and we also have 5 columns. Okay, so this is a dimension of 3 by 5, and the mid vector we also have a 1 by 5. Okay, so we are stacking the top matrix on the mid vector. Okay, so this is about the mid vector. And then we also need to construct the bottom vector. Let's run the bottom vector here. Okay, bottom vector, we have 1, 1, 1, 0, 0. So let's go back to the slides. Okay, now you can see it's very clear. It's very clear. Okay, we have a 1, inverse 1 vector. Okay, 1, 1, 1 followed by 0, 0. Okay. Let's go back to the slides. Okay, so this is about coding. And then you can see now we are combining top, middle, and the bottom vector together so that we can construct an A matrix. Okay, so let's just do it here. So now you can see, check the A dot matrix. Okay, now you can see this is the fully constructed AX matrix. Okay, AX, you can see this is 5. What's the dimension of this? 5 by 5, right? 5 by 5, 5 rows, 5 columns. Okay, so you can see the first, this is 2 times the sigma covariance matrix, and followed by the mu vector. Okay, mu vector and followed by the 1. And then we also have a mid vector. Mid vector is 1 by 5 vector. The bottom vector is also 1 by 5. So it makes our A dot matrix. Okay. And based on the A dot matrix, okay, and then we can also create a B vector. So what is B vector? Okay, B vector, we have a 0. You can see here, this is the 0 vector, the 0 vector followed by the mu p and followed by the 1. Okay, so how to construct this? Let's go to the codings. Okay, B vector, now you can see. Okay, now you can see we have a row vector 0, 0, 0, and then we have a 0.005. So this is the specified risk portfolio return. Okay, portfolio return, and followed by the 1. So let's go back to here. Okay, so you can see this is 0. Actually, this is in both phase. We have a 3 by 1, okay, 3 by 1 vector, and this is the specified portfolio return, and followed by the 1, okay. uh, Maybe it's a little bit difficult for you to understand the formula, but all you have to know is that, okay, you can treat this as a formula. Basically, this is a formula, and of course, in the future, maybe you don't have to worry about the formula here, because we already have many packages out there to help you to calculate the MVP, so you don't have to worry about the formula anyway. But of course, in the future, if you want to uh, do some more advanced studies in portfolio analysis, probably you need to understand the formula behind that. Okay. Okay, so this is the codings we have here. Okay. And then, okay, let me finish and then we can take a break, because now we have A matrix available. We also have a B vector available. Then we can calculate Z, right? So what we are doing here is to calculate Zx. So Zx will be equal to the inverse of Ax multiplied by the B vector. Okay, so we can just calculate the, okay, we use solve to get the inverse of A matrix multiplied by the B vector. Okay, let's run this. And let's just check out the first 3 elements of the Z matrix, because it refers to the weightings of our 3 asset cases, 3 asset, okay, 3 firms. So I'll call it as a W dot R0, okay. So you can see the result here, W dot R0 here. Okay, now you can see the weightings for the Nordstrom, Starbucks, and Microsoft. Okay, and of course you can check out the sum of the 3 asset weights will be equal to 1. Okay, so this is about the weightings for 3 firm data, and this is the MVP for given return, for given portfolio return. And based on the weightings, then you can also calculate the expected return to verify if the return is equal to 0.005. So let's run this, and we have a mu dot zero R0, mu dot R0. Okay, so you can see the result is equal to 0.005. It's consistent with our specified portfolio return. Okay, and then we also can also calculate the standard deviation. Standard deviation is following the formula here, and we can calculate standard deviation here. Okay, standard deviation is 0.0968. Okay, so that's about the GMVP and the MVP for given rate of return. Okay, so let's take a break and we'll be back later. Okay.